Okay, so when you study for a test, what you want to do is you want to go through each section and look for vocab, but then you also want to practice problems. So in section 1.10 is the first section that's on this next exam, talked about scatterplots. And if you look at the next page, they define a scatterplot. Remember, a pie chart is part to total or part to whole. Bar graphs are part to part. Scatter plots, you have two numbers and you're looking for correlation. And remember, you need label, label, title, consistent units. But remember, if you skip a bunch of numbers, you do the zigzag thing. And if you skip a bunch of numbers, but then you have to be consistent after that. Remember, independent and dependent variables. X is always going to be our independent variable. Y is always going to be our dependent. And we need consistent scales. And again, sometimes I would redo problems in the book that we did together. And here again, it tells you what you were supposed to learn. All right, so let's just look at an example that kind of goes with this. Again, temperature, we're comparing two numbers with ice cream sales. So this is a scatter plot. X and Y. X is always your independent and dependent, because I think that ice cream sales are dependent upon how warm or cold it is outside. So X is your independent variable, Y is your dependent, and so I'm going to make my little XY axis, and this is just a graph that is missing the other quadrants. You're only graphing the positive quadrant here. You have to start at 0, so you can't, and numbers have to go up in consistent units. So even though I have an 88 and a 75, it looks like, you know, 10s are going to do it here. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90. And again, you want these equally spaced, and we're going to label those 30, 40, 50, 60, 70, 80, 90, and these are degrees Fahrenheit. And again, X is always first. X always goes on the X-axis. And that's your independent variable. Dependent, these seem to go by thousands for the most part. So I'm going to go by thousands. So here's like 2,000, there's 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, and then 12,000. And I could label all of them. I'm just labeling my even ones, but I put hash marks where my thousands are. And this is money. And then I could say, I don't know, temp versus ice cream sales or something like that to give it a title. All right, so now I'm going to graph these. So I'm going to go over to 20 and go up to 2,000. And then I'm going to go over to 30 and go up. Now it's halfway between there because it's not 3,000. 45 is partway between 40 and 50, and then it's not quite 3,000, so just a little bit shy of 3,000. 60 is at 5,000, so that's going to be there. And then at 75 degrees, which is partway between 70 and 80, it's up at what, 10,000? So right there. And then at 88, just shy of 90, it looks like it's going up to what, 12,000. Okay. And again, it might not be perfectly straight, but you can see that there's kind of this trend here that's kind of going in the middle. And it's going up, so we call that a positive correlation, and then we explain what that means. So it looks like the warmer it gets, the more ice cream they sell, which makes sense, right? People don't eat as much ice cream when it's in the winter. So then you'd explain this and say, as temperature increases, right, goes up, ice cream sales also go up or increase. Okay, so those are the big ideas from section 1.10. All right, I'm going to pause it for a second. Why don't you flip to section 1.11 on page 93, and then we'll catch up there. Okay, so I flipped through this section. This is section 1.11, our converting units, and there really wasn't a lot of vocab in this one, so it was more knowing the chart for metric and then knowing dimensional analysis to convert just numbers and rates. So I want you to pause it here. I want you to try converting all of these on your own, see how you do, and then unpause to watch the explanation. So pause it right now, see how you do, and then I'll come back and explain all these. Okay, so let's look at these here. On the first one, you make your chart, 3 wings, main units. Kila are the big ones, milli are the tiny, and centa are right here. So I want to go from kilograms to centigrams. So that's 1, 2, 3, 4, 5 jumps. And so my decimal's at the end of the number, so it has to go 5 jumps. 1, 2, 3, 4, 5. And I'm going from big to little, so every jump I'm multiplying by 10 over and over again. So that's why the decimal moves that way. And so if I move it that many jumps, it looks like I got 40 million centigrams. Okay, remember, if there's no decimal, it's at the end of the number. All right, the next one, I still have my chart. I'm going from millimeters to meters, so that's 1, 2, 3 jumps. So my decimal's right here. So I moved it 3 jumps to the left, 1, 2, 3. And I'm going from little to big, so I should have less of them. So as I go this direction, I'm dividing by 10 3 times. And so I got that. All right, next one, do dimensional analysis. You have seconds. So I started out with seconds. I have seconds on top, so I put it seconds on bottom, and there are 60 seconds in 1 minute. So then those cancel. Now I have minutes, so I put minutes on bottom, hours on top, and again, there's 60 minutes in 1 hour, so the number 60 follows the label. Hours on top, put hours on bottom with days, and the numbers follow. There are 24 hours on 1 day, so 24 has to go with the hours. And then it looks like I have my unit of days, so I multiply everything on crossed, and I got 400,000, and then I multiply everything on bottom, and I got 86,400, and then you divide in order, so you type this number divided by that number, okay, and I got 4.6 days, so I got that. The next one, and again, you only start when you have a number, you don't have two things, you just start out with a number, and then you have your little fraction guys. Days are on top, I put days on bottom, and I know 1 day has 24 hours. Hours is on top, so I put hours on bottom, and I know there's 60 minutes in 1 hour, so the units follow the labels. Minutes is on top, put minutes on bottom with seconds. Again, I know 60 seconds are in 1 minute, so the numbers go with their labels. Everything on top gets multiplied, everything on bottom, but again, dividing by 1 doesn't do anything. So I got 2,592,000, I think, seconds. All right, so let's look at the next one, or 592,000, sorry, 2,592,000. I didn't finish what I was doing there. Feet, same thing. I start out with feet. It's just a number, so it starts out kind of by itself. Feet are on top, feet are on bottom. I know there's 12 inches in 1 foot, so the 1 has to go with the foot, the 12 inches has to go up here. And then I know that 1 inch is 2.54 centimeters, so cancel inch, and I get centimeters, and I'm done. So everything on top gets multiplied, everything on bottom gets multiplied and divide, but again, dividing by 1 doesn't do much. So I got 243.84, or 243 and 8400ths. Now, the last one is a rate. So with rates, you start out with 2 numbers at the beginning. The other ones, you just start out with 1 number because you're converting 1 number, but rates have 2 labels. So you start out with 2 numbers. So I decided to cancel miles first. Miles are on top, miles are on bottom, and I know there's 5,280 feet in a mile, and then these cancel. All right, and I like feet because I want feet per second. So now I'm going to go back for my hours. So hours on bottom, I put hours on top, and I know there's 60 minutes in 1 hour. So then these guys cancel. Now I'm in minutes. Minutes are on bottom, put minutes are on top. I know those go to seconds. And again, there's not 60 seconds in a, or 60 minutes in a second. It's 60 seconds in a minute. So again, that 60 follows the label. The labels determine where the 60 goes. All right, and now I'm in seconds, which I want. I want feet per second. Everything on top gets multiplied. Everything on bottom gets multiplied. And then you divide in order. So the numerator divided by the denominator, and I got 36.7 feet per second. So again, if you're in town and you're driving 25 miles per hour in a residential area, if you look away for 1 second, you know, you're about 37 feet goes by in that 1 second, and you're not really even driving that fast. So if you look away 2 seconds, you'd scale that by 2, 3 seconds, scale it by 3. So again, when you're in a car, things move a lot faster than people think. All right, why don't you pause and go ahead and look at the next section and see if there's any vocab words that are bolded, and then I'll give you some problems to try here. Okay, so I want you to try these here, and again, these are percent increase or decrease, so figure out this is what it started at and this is how it changed. So figure out the percent increase or decrease, and then see what the new salaries are if they go up by 5%, and see what the new price. So here I don't want to know the discount, I want to know the new price. Oopsie, new salaries, I guess here. And then here I want the new price if there's a 30% discount, what would the new price be? And then I want to say during COVID, someone makes $50,000 a year and they have to take a 10% pay cut just because of the loss of money that the business had. And then say a year from now, they get that 10% raise back. Is their salary the same as what it used to be? So I want you to kind of analyze that. So I'm going to put these here. Again, I want you to try these on your own, and then I will come back and explain them. Okay, so remember to find the percent increase or decrease. You always subtract and you find the difference between the two numbers. And then you always divide by the starting number or the beginning number, whichever one you started with. And again, since it's a percent, you multiply by 100 to convert the decimal into a percent. So I subtracted these. I got 30 pounds. You always divide by the starting weight. And notice units cancel when you do percents. They have to match times 100, and I got about 20.7%. Okay, the next person, again, I found the difference. I subtracted. I got 14 pounds divided by the starting weight. Always divide by the start. Again, your units cancel. That's why percents don't have pounds or dollars or anything. They're just percents. Multiply by 100 to convert the decimal. I got about 7.7%. The next one, maybe your favorite cereal or your favorite cookie or something went up by 50 cents. So you subtract to get that it went up by 50 cents, divide by the starting price. Again, the money cancels, multiply it by 100, and your answer is exactly 20%. So if at the grocery store they raised it by 50 cents, that might not feel like much. You're like, it's just 50 cents, but it's actually 20% of the price. That's a pretty good increase on a grocery item. All right, the next one, say that you used to make $12 an hour at your job, and maybe you get a job at Target and they pay $15 per hour. So you just switch jobs. So you have one job and now you make 15. So your change when you subtract is $3. But your original salary or hourly rate was $12. Again, so you take the difference, subtract, divided by the beginning. Always divide by the beginning, the beginning, the beginning, the beginning. Multiply by 100, and exactly 25% raise, which is huge. Most people are lucky to get, 1-2% raise, if any. So just by switching jobs, this person got a 25% increase in their wages, just from maybe going from, I don't know, McDonald's to say Target. Okay. The next one, to do a 5% increase, you can multiply by 0.05 to get the increase and then add. But remember, the faster way is to add the 5% to 100. So you have 100% plus 5%, so it's 105% or 1.05, 1.05. And remember, we call this a multiplier. And it gives you the money with the 5%. So if I multiply and multiply, the new salary is 21,000 and the new salary is 52,500. So I could do 0.05 multiply times 20,000 and then add. Because remember, when you use a percent, you always multiply. But it's faster to just add that 5% to 100 and use 105% to go get the new price. Okay, happen if there's a 30% discount at a store. Again, to use a percent, you multiply. You could multiply by 0.30 and subtract that discount. That would give you your discount, and then you could subtract that from the price, but that's a two-step process. All right, so for example, if I had an $80 coat, I could multiply it. I don't know if you can see that very well. Let's see if I turn the lamp on, if that helps a little bit. So if I $80 coat, I could multiply by 0.30, but that just gives me a $24 discount. I still have to subtract it from the price to get the new price, so $56. So remember, the faster way is to multiply by the multiplier, which is, on a discount, would be 70%, and I get the $56. So remember, if you have 100% and you subtract 30%, you're only keeping 70%, and that's where that multiplier comes from. So instead of getting the discount and subtracting, I just multiply by my multiplier and it gives me my new price. Okay. And then remember, with percents, you can't really undo them because they're moving targets. So if you get a 10% pay cut, again, you're losing 10%. So 100% minus 10% is 90% that you're keeping. You multiply this as your new salary. All right, now, say after a year they raise it back up, okay, so that's above, so 100% plus 10% is 110%. That doesn't quite get you back to where you started from, because remember, percents, you can't add them or go back because it's kind of like a moving target a little bit, so that changes. All right, so that's a good review for those two sections. I'll make another video to help us review some other sections too.